Hello everybody, today I am back with another video, and today I'm going to be covering a topic called asymptotic equivalence. This is a topic that is in calculus and it is used in Taylor polynomials. It is not taught in BC, Calculus BC or Calculus AB, but it is a topic used if you're taking like Calc 3, a third year calc course, I think. If you're taking something like that, then you might find asymptotic equivalence to be useful. Today I'm just going to go over the term, what it means, and show one example of it, a familiar example at that. So either way, let's get right into it. And let me go a little closer to the camera, whiteboard. And so what asymptotic equivalence is the limit as x approaches a of f of x over g of x. That is equal to 1. So if you have two functions, f of x and g of x, divide them, find the limit as x approaches a. If that equals 1, then that means you have asymptotic equivalence between f of x and g of x. So the proper notation for this is actually not the proper notation, this is just how you prove it. But the actual notation is as x approaches a, you put a comma here, and then f of x, put g of x, and to show that they're asymptotically equivalent, you put this little tilde sign. And that shows that as x approaches a, f of x is asymptotically equivalent to g of x. And how do you know that they're asymptotically equivalent? Well, when you divide them, find the limit as it approaches a, it'll equal 1. So, one popular example that may come to mind, you probably have seen this if like earlier in your calculus classes, particularly in Calculus AB, BC, or in Calc 1. You may have seen these, but basically what it is an example of two asymptotically equivalent functions, and those two, so let's do this right here, f of x, we have f of x, and we're going to say 0, we're going to put a as 0 actually, and we're going to have sine of x, so sine the trigonometric function, and over x, and you know that that's equal to 1. This is an example where there are two asymptotically equivalent functions, sine of x and x. So why are they asymptotically equivalent? If you solve this out, this is actually true. As the limit as x approaches 0 of sine of x over x, it does equal 1. Other asymptotically equivalent functions, you guys can try to find that out, but that's where I'm going to leave this video. It's kind of short, but I was just trying to define this term, asymptotic equivalence. Very basic understanding. There's nothing complicated in this video. Hopefully nothing too complicated. I think I did talk a bit fast, not sure, but either way, I hope you guys did find this video helpful. If you did, please be sure to leave a like and subscribe. Thank you guys so much for watching this video, and for your continued support on the channel as well. Thank you guys so much for watching.